Hello everyone, I'm Shiv and today I'm going to talk about the acceptance rejection method from the course of probability and statistics. Uh, Coming to the topic itself, uh, introduction to acceptance and rejectance method. The acceptance rejection method is a technique used to generate random samples from complex probability distributions. This is particularly useful when direct sampling from target distribution is difficult. This method relies on comparing the target distribution with simple proposal distribution. So how this method works is this part the this acceptance rejection method is used to generate random samples in complex probability distributions where a large amount of samples are taken to have the exact probability. This technique is used to create many random samples to get the proper complex probability distribution, like how it is properly distributed. It is This method is particularly useful when direct sampling from target distribution is not possible, like uh, taking a direct sample from the target and to use it to distribute is very difficult. We may take multiple samples from the probability system, and we can use the multiple samples by this method to get the probability distribution. This method relies on comparing target distribution to simpler proposal distribution. Well, coming to the purpose of the method, the main goal is to obtain samples that follow a specific target distribution. It enables simulation in scenarios when analytical solutions are not feasible. This method is widely used in Monte Carlo simulations and Bayesian interference. So the main goal of using this method is to obtain samples that follow a specific target distribution. While the final reason we need to achieve the proper complex probability distribution. Uh, in this first, the primary goal is to obtain samples which follow a specific target distribution. From the complex distribution, we have to maintain different samples with a specific target distribution. Uh, this specific targets, these distributions help us simulate scenarios when analytical solutions are not possible, not feasible enough. Like we can simulate in different scenarios. This method is widely used in Monte Carlo simulations and Bayesian inference. Coming to the basic concept of this method, the acceptance rejection method involves proposing samples from an easy to sample distribution. Each proposed sample is either accepted or rejected based on a specific criterion. Accepted samples from a set form a set that approximates the target distribution. So, the basic concept of this method is the acceptance rejection method. This involves in proposing multiple samples from an easy to sample distribution. So, it involves proposing samples from the complex one and uh, to take it in an easy to sample way. Each proposed distribution it can be either be accepted or rejected based on a specific criterion, like how the particular sample has been selected. If it's been to the selected to the proper criterion, uh, in the basis of that, a sample can be either accepted or rejected. So uh, the samples accepted ones form a set that which help us approximate this target distribution. Coming to the key components, the target distribution f of x that we want to sample from, f of x is the target distribution. The proposed distribution is g of x, which is easy to sample. A constant or c is such that f of x into g of x for all of x. Well, coming to the algorithm step by step, we at first we generate a sample x from proportional distribution g of x. From g of x, we get a sample of x. Uh, we generate a uniform random number which is denoted by u, which should be between 0 or 1. We accept the sample x if u is less than ratio of f of x by g of x. Otherwise, we reject it. Like uh, to accept the sample of x, we need to check if the the ratio of f of x by g of x is less than u. If u is less, then we'll accept the sample, then the ratio. If u is less than the ratio, we accept the sample. If not, we reject it. That's how this works, the algorithm. Coming to choosing g of x and c. The proposal distribution g of x should be easy to sample and cover the support of f of x. The constant c must be chosen so that f of x c by c times g of x for all of x. A good choice minimizes the rejection rate, increasing efficiency. So there is a proportional distribution g of x. It should be easy to sample from the support of f of x. We have the f of x sorted out earlier. Through this, we can get this g of x easily. The constant through the formula previously showed must be chosen so that f of x by g of x is for all of x. A good choice of c. This minimizes the rejection rate, which will also help in increasing the efficiency. Efficiency and rejection rate. The efficiency of the method depends on how closely c times g of x bounds the f of x. The rejection rate is approximately 1 minus 1 by c. Lower rejection rates means fewer samples are discarded, improving computational efficiency. So how the efficiency and rejection rates are worked is the efficiency is mostly dependent on how closely c times g of x, which is bounded by the f of x. Like how f of x is bounds the c times g of x will decide how the efficiency of the method. The rejection also is based on 1 minus 1 by c. By substituting c in here 1 minus 1 by c, we can see how much the rejection rate is approximately. How much the lower the rejection rate, that means the lower the samples are discarded, which improves computation efficiency and accuracy in using this. Uh, Coming to advantages of this method, it is simple to implement and understand. It can be used with a variety of distributions. It does not require the normalization constant of the target distribution. So, by using this method is very easy to understand. It can be used with a wide variety of distributions. Uh, so the method is very simple, seen earlier. It has a easy formulas. It is also easy to understand too. It can be used in a wide variety of distributions. It can be used anywhere in anywhere. It doesn't require any normalization constant. Like the normal constant, it doesn't require for target distribution. Coming to limitations of the method, high rejection rates can lead to inefficiency. Choosing an appropriate proposal distribution and constant C can be challenging. It may not be suitable for high dimensional problems due to low acceptance probabilities. So there are high rejection rates in this, as we talked earlier, due to the sampling rates, which may lead to inefficiency and inaccuracy. Uh, by choosing an appropriate proposal distribution and constancy is very challenging because there may be a large amount of samples too. So getting an appropriate proper proposal distribution and constant is very difficult and challenging. This method may not be suitable for high dimensional problems due to low acceptance probabilities. Uh, Coming to applications of acceptance and rejection method, this method is used in Bayesian statistics for posterior sampling. It is also employed in Monte Carlo methods to generate complex distributions. It is also applied in simulation models such as physics and finance. So as it said in the start, it is using Bayesian statistics, which is for posterior sampling, interior and posterior sampling. Which you remember, this is used in the posterior part of the statistics. It is also employed in Monte Carlo methods to generate complex distributions. In Monte Carlo methods, this acceptance and rejection method is used to generate complex distributions. While this generates sample distributions, in Monte Carlo it is used to generate complex distributions. It applied in simulation models such as physics and finance. As I said, it is useful in simulation. Uh, Coming to an example scenario, suppose we want a sample from complicated density of f of x. We choose g of x as a uniform distribution over a suitable interval. Then we apply acceptance rejection algorithm to generate samples effectively. There is an example scenario here. If we want a complicated density f of x, we want a sample from this density of f of x. So we choose g of x as a distribution over a suitable interval. So f of x is a density and g of x is an interval. We want a sample from this density by using this interval distribution over use suitable interval. Then we apply the method as I talked about by taking over the C and using the method to generate samples through which we use the rejection, we reject or accept it if it's less than u by using the formula like f of x, if u is less than f of x by g of x, we reject it, or if less we accept it, if more we reject it. So through which we can get the sampling rates, and we also can use to generate samples efficiently. Coming to the conclusion, the accept and rejection method is versatile technique for random variate generation. Its effectiveness depends on selecting a good proposal distribution and constant. Despite some limitations, it remains a fundamental tool in computational statistics. Well, this method is a versatile technique for random variable generations. Like we use it to generate samples, which counts for the variate generation. Its effectiveness depends on selecting a good proposal distribution and the constant. Uh, Being due, even if having some limitations on proposal distribution and constant, it remains a fundamental tool in computation statistics. So this is how this uh, method works. Thank you for listening to the presentation.